So we can extend this idea a little bit in talking about three-dimensional shapes, a little bit more real-world application. Right? So if we have water that's draining out of a conical tank, the water inside that tank is at some height. And maybe we can measure how much water is coming out of the tank or the rate at which the water is coming out. So we can measure it's draining out of the tank at 1 liter per minute, or 2 liters per minute, or 1 liter per hour, or something like that. And we might ask, well, how is that going to change the height? How is the rate of change of the height going to relate to that rate of change of the volume? So again, we start off with a relationship amongst the variables, amongst the amounts themselves, not the rates. And again, we're going to take the derivative with respect to time of both left and right. So you see here that on the left I just have v, but on the right I have a product of r squared and h. So when I take the derivative of that with respect to t, I have to use not only the chain rule in both cases, but I also have to use the product rule. So I take the derivative with respect to t of the left side, dv dt, and on the right I have that pi over 3. I use that as just a coefficient, so I leave that in front, and I take the derivative of this product. So I have 2r dr dt times h plus dh dt times r squared. You can see in both, especially in both cases, but really it's only obvious in this case. Here I had to use the chain rule. When I took the derivative of that r squared, it was 2r times dr dt. When I take the derivative of h, I just get dh dt, because again, in all cases I'm taking the derivative with respect to time. And so now, as long as I have some known quantity, I know how much water is coming out, or the rate at which it's coming out, I could figure out how fast this height is changing, or I could figure out, maybe I'm looking for how fast is that radius on the surface of the water changing. All right, the general rules for solving related rates problems. We're going to make a sketch and assign given quantities. We have knowns and unknowns, just like in a physics problem. We're going to write an equation using variables from step 1, and this equation shouldn't involve any rates, so we're just writing an equation relating the amounts or the quantities themselves. Then we're going to differentiate implicitly with respect to time, and then we can substitute what we know to find out our unknowns.